Hello there, 10th graders. This is teacher Krishna, and welcome to our physics class for week number 15. Hey, one more time, thank you a lot for entering our online lessons, and of course for completing all of the assignments that you have had so far. So keep it up, please. Before we start, just like every week, log into Agilix, enter the Google Classroom. Of course, download your Word document for the summary, save it in the physics folder, and name it as it is specified right below. As we move, remember to take notes on the Word document. That is something essential so you can keep track of the most important information from this video and PowerPoint presentation. It's always important to start with our end in mind. And this week we're going to study topic 2.09. And our end in mind is interpret information correctly from motion graphs. It's a very simple topic, but you still need to analyze in order to complete the assessments correctly. So just like I mentioned, we're going to talk about motion graphs. So graphs can give you a lot of useful information and in a better way to visualize it. So what happens is that whenever we are studying physics principles, there are a couple of things that might not be very obvious whenever we just analyze any kind of problems related to what we're studying. But once we put all of that information we have from the problem inside a graphic, then we can start to notice certain connections, or just like I mentioned, things that were not obvious at first. That's why we're going to analyze graphs one more time. So, we're going to have a couple of questions for the graph that we have right here. Just like you can notice, is a graph that is taking into consideration time and position in meters. In the x-axis we have the time, and in the y-axis we have the position. So the first question that we have, which phrase best describes the speed? So speed is increasing, speed is constant, or the object is not moving. Okay, so let's go to our graphic. So just like you can see, when 1 second has passed, then you can notice that the object has moved 1 meter. Then when 2 seconds have passed, then it has moved 2 meters. So basically, what we can see right here is that the speed is constant. Why? Because of the slope from the graphic, we can see that the line only follows one certain direction, and we don't have any sort of curves around. So basically, it's just a straight line that is going upwards, and without any variation. So that's basically what tells us that speed is constant in this specific problem. Now, it says, how far did the ball roll by the end of 4 seconds? Alright, so let's analyze it. We can go to the period that is specified in 4 seconds. And if we follow the information from the y-axis, we can see that it has moved 4 meters. Then the next question, we have how fast was the ball rolling at time equals 4 seconds. Well, basically what we can see right here is that since it has a constant speed, it was moving basically 1 meter per second. Okay, so basically at 4 seconds, it was moving at the same speed. It was still moving at 1 meter per second. Sometimes it might be a little bit tricky because of the slope of the graphic that we have in here. And we might think that the higher it gets, then the higher speed it acquires. But in reality, because of the data that we have in the x-axis and in the y-axis, we can notice that it is not that way. So basically, right now, no matter if only 1 second has passed, or 3, 4, etc. have passed, what happens is that the object is moving at a constant speed. Okay, now we have position versus time. So position versus time represents speed. So here we have the formula: speed equals distance divided by time, or position divided by time. And the slope is constant, which means the speed is constant as well. So one more time, here we have one graphic that is pretty similar to the one that we had before. The difference is that the position is a little bit different. So just like you can see right now, the slope is basically the same as in the last example. And just like I was telling you, it is just a straight line that is going upwards at a constant rate. So since it has no great variations, we can assume one more time that the speed it's constant during the whole problem. Now my question is, how do you calculate the slope of this graphic? So remember that when we talk about the slope, is basically the line that is coming from 0 from both axes, and then it ends up in 5 in the time and in the position of the meters as well. So how are we going to calculate that relationship? So, well, for this graphic specifically, you need to take the centralized values. Start with the first value and finish with the last. Check the change in the values from your graph and apply the following formula. So, in order to calculate the slope, you need to take into consideration the change in y as well as the change in x. So here you have it. And here is very important that you notice only the points that are marked right here. So you can notice that only the point that is specifically placed in 1 and in 4 are marked. So we are only going to work with the information that we have right here. Okay. So we're going to start with the change in y. So you can notice that in y, in the y-axis, the first point that is marked is exactly at 10 meters. And where is the last one? The last one is at 40 meters. So 40 minus 10 will equal 30 meters, of course. So that is the first value that we need. The change in y will be 30 because we go from 10 to 40. It is a change that it has suffered. How about in the x-axis? Let's check. So we have from 1 to 4. So 4 minus 1 equals 3 seconds. So that is basically the change in the x-axis. Alright, so now if we divide the 30 meters that we had in the change of the y-axis by the 3 seconds that we had in the change in x, we're going to find that the slope of this specific graphic will give us a total of 10 meters per second. Alright. Now we're going to go with another one, which is velocity versus time. So the slope of the graph is the acceleration of an object. So here we are analyzing acceleration because it's a relationship between velocity and time. We have that the process and formula are basically the same as we specified it in the last problem. So basically, if we want to find about the slope, we can just take the first point that is placed in number 1 and in number 4, and then we can take the information from there in order to calculate the slope. But what if you want to find the area of the triangle that is formed in there? And of course, what does it represent? Why do we want to find the area of the triangle that's formed in there? Well, now we're going to remember a little bit of mathematics. So in order to find the area of a triangle, we are going to have that the formula corresponds to 1 divided by 2 multiplied by the base and multiplied by the height of the triangle. And basically the area of the triangle that you have in your graphic, it represents the distance that the object has traveled. So in this case, the total distance that the object traveled in this specific graphic was 62.5 meters. So let's analyze the graphic a little bit right here. So we need to find the values for the base and of course for the height. So we're going to find the value of the base in the x-axis. So the x-axis is basically number 5 because it covered all in there. And in order to find the height, we need to focus on the value that we have in the y-axis. And we can notice that the last value from our graphic in there actually managed to get to the velocity of 25 meters per second. Okay, so basically with these values, you can substitute them inside the formula and you can get the result of 62.5 meters. Now we're going to go with acceleration versus time. So question, what interesting facts can you find in this section? And what hints can you find to support your understanding? So now I will ask you to go to Agilex and search for the acceleration versus time graphic and all the explanation from there. So you can find what other interesting facts and relationships you can find in the representation of the graphics and the values that there are. In that specific section, you are going to find some hints in order to double check your understanding. So make sure to read them and of course make sure to write them down on your Word document so you can take them into account for further exercises that we have to complete. And you have an exercise. You have to go to page number 3 and complete all of the exercises that you encounter in there. So all of the graphics that you will find are related to the principles that we already analyzed. So I'm pretty sure you are not having any problems with that. And lastly, what is the evaluation? Read and summarize topic 2.09. At this point, I'm pretty sure that you have done it already. And you have to take the quiz for topic 2.09. The quiz has a value of 5 points. And this week, we had to work, actually another topic, we had to work on topic 2.10. But I didn't want you to have too much content, so you could actually finish everything on time in the schedule that we had assigned for the physics class. So we're going to have part of the evaluation today that are basically the 5 points from the quiz, and we're going to complete the other 5 points from the evaluation next week. So that's it for today's lesson. Thank you for coming, and I will be seeing you next week. Goodbye, guys.